million.
Hello viewers, welcome yet again to another math lesson for the upper basic level. And as usual, before we go on to today's lesson, we are going over the assignment that I gave you the last time. I gave you two questions to try. Number one was find the complements of 50 degrees, 20 degrees, 55 degrees, and 45 degrees. And number two was find the supplements of 142 degrees, 105 degrees, and 95 degrees. Now we start with the number one. Number one, we are looking for complements, and we know complementary angle 180. Sorry, they add up to 90 degrees rather. Three angles add up to 90 degrees. So, if in A, one of the angles is 50, we assume the other angle is x because we don't know its value. And we know if we add those two angles, we should get 90 degrees. So we can x plus 50 is equals to 90 degrees. And from there, we just undo the 50, subtract 50. And then the 50s will cancel each other out from the left-hand side. So you get x as 90 minus 50 should give us 40. So the 50 degrees is 40 degrees. Move on and do the same thing. This time you are given an angle of 20. The second angle is not given, so we assume it to be y. Again, they are complementary. So if you get 90 degrees, then again, solve this by undoing the 20. So you subtract 20 sides of the equation. The 20s will cancel each other out from the left-hand side, and therefore you have y being equals to 90 minus 20 should give us 70. So this complement of 20 degrees is 70 degrees. Then letter C, you are given an angle of 55 degrees. The complement we don't know, so we can use M. Again, the two of them we should get 90 as our sum. So that means M plus 55 is equal to 90 degrees. 5 from both sides of the equation. The 55s will cancel each other out. Then you have M as 90 minus 55 should give us 35 degrees. So therefore the supplement of 35 degrees. And then finally, you are given an angle of 45 degrees. The complement we don't know, so we can use a variable. And again, we know P plus 45 is equals to 90. Okay? Subtract 45 from both sides. That gives you the 45s cancel each other out. P is 95. No, 90 minus 45 should give us 45 degrees. So therefore the complement of 45 degrees is 45 degrees because 45 plus 45 is 90. We are looking for supplements from the word supplementary, and we know that supplementary angles add up to 180 degrees. So if in the first part we are given an angle of 142 degrees and we are asked to find its supplements, which we don't know, we can use it. We know if we add the two, we should get 180. So that's simply going to give you x plus 142 is equals to 180. Then you subtract from both sides. And the 142s will cancel each other out. You have x now being equal to, if you subtract 142 from 180, that should give us 38 degrees. So therefore, the supplement of 142 is 38 degrees. Then the B, you are given an 140. You are asked to find its supplement. We don't know, so we can use y to represent it. Again, we know 105 should give, because 3. Subtract 105 from both sides, and this 105 will cancel each other out, and you are left with y equals to, if you subtract 105 from 180, that should give us 5. So therefore, the supplement of 100 degrees is 75 degrees. And then finally we go to the C, and C, you are given an angle of 95 degrees. The supplement, given x to represent it if you want, and we know if you add the two of them, we should get 180. So that means x 95 is equals to 180 degrees. Subtract 5 from both sides of the equation. This 95 will cancel each other out. We have x as, if you subtract 95 from 180, that should give us 85 degrees. So the supplement of 95 degrees is the angle 85 degrees. That was the correction to assignment. Then we move on to our lesson for today. And as you can see clearly on the screen, we are looking at, or we are starting lines. Okay, so parallel lines. Say parallel lines are lines that move in the same direction without ever meeting. That means they are lines that move in the same direction, but they would never meet. The lines do not meet because they maintain the same distance apart. That is why the lines never get to meet, because they move in the same direction, but then they maintain the same distance apart. So they can keep going on forever, but they would never meet, all right? Like if you stand at one point and your friend stands a few meters away from you, if both of you maintain that distance between you and you move in the same direction, you will never get to meet, all right? So you'll be moving in parallel lines. So parallel lines are lines that move in the same direction, but they never meet. They never meet because they maintain the same distance apart. Now, of course, what you see on the screen are just examples of parallel lines you have there, which means they can either be horizontal, they can be vertical, or they can be slanting, all right? But what is important there is that they move in the same direction and they maintain the same distance apart, so therefore they will never get to meet. Like you can see the first one, the horizontal lines there, AB and CD are parallel because they're moving in the same direction, but they will never get to meet. Likewise, the second one, the vertical lines, they are still moving in the same direction, that is X, W, and Y, Z. They move in the same direction, but they never get to meet. So they are also parallel. And then you see the other ones that are slanting, P, Q, and RS. Those two are also parallel. Why? Because they're moving in the same direction and they are maintaining the same distance apart, so they never get to meet. So those are also parallel. Not just see lines and assume they are parallel. Like if lines like now, that alone is not enough information for you to lines. You need more information than just this. Either you have arrows to indicate they are moving in the same direction. That indicates they are parallel. You need that. Or in the absence of these arrows, then some letter. If this is A is put, B is put here, C is C. So you have line AB and line CD. Still, you need to have something like this. You read this as AB is parallel to CD. Alright? So you must have either the arrows to indicate it or something like this. The lines are labeled and then you are told that AB or whatever letters are parallel to A. Otherwise, you cannot assume that any lines are parallel. Then we look at what a transversal. A transversal is a line that cuts across parallel lines. A transversal is a line that cuts across parallel lines. So whenever you have parallel lines, any line that cuts across them is called a transversal. Like you can see on the screen there, you have line AB and CD being parallel, and then line PQ is cutting across them. So that line PQ there is a transversal. Okay? Now this is important. Whenever a transversal cuts across two parallel lines, 8 angles are formed. When a transversal cuts across two parallel lines, you will always have 8 angles being formed. Now we are going to need this. Angles are formed whenever two straight lines meet. So if this line and that is a straight line and they meet here, so therefore an angle is formed there. Okay? Also, if you look at this is a straight line, that is another straight line. Meet here, another angle is formed there, so you get that as 2. If you take this straight line, they meet at a point, so they form another angle there. That gives you the third angle. And then, straight line, they also meet, they form another angle, and that gives you your fourth. So you have 4 angles up there. Now when you come down here, again, you have this straight line, they form an angle. That becomes our, say, the straight line meeting with the straight line, form an angle here, which we call angle. And then you have this straight line. With this straight line, they meet at a point here, they form another angle. 6th angle. This straight line and this straight line, so therefore they form an angle there. And that is our 7th angle. This straight line and they form an angle there, and that gives you our 8th angle. You can see whenever a transversal cuts across two parallel lines, 8 angles are formed. Now let's group these 8 angles. If you look at the diagram very carefully, between the two parallel lines, there are 4 angles there. Like angle 3, 5, 6 are the angles that are found between the two parallel lines. And we are going to call those, we are going to need that later on. The other angles now that are not between the two parallel lines are our outside angles. So angle 1, 2, angle 7, and angle 8 are our angles. So therefore it means 4 side angles, side. The inside angles are the angles that are found between the two parallel lines, okay? That is going to be useful to us. Right. What you can see on your screen is alternate angles. Okay? Alternate angles. You said these are two inside angles that are on opposite sides of the transversal. These are two inside angles that are on opposite sides of the transversal. And what I have there is an easy way of remembering what they are. Inside, inside, opposite sides. Which means both angles are inside, but they are on opposite sides of the transversal. Now if you go back to our diagram, you can clearly see here, if we take angle 3 for example, it is an inside angle. Alright? Also, if we take angle 5, that is also an inside angle. But are they on the same side of the transversal? No, they are not. So therefore, we can say angle 3 and angle 5 because they are both and they are also not they are on opposite sides of the transversal. Now, apart from identify any angles that are also alternate here. Two inside angles that are on transversal. Clearly, we can see that and angle 6 are alternate and they are on opposite sides of the transversal. That angle 3 and angle 5 are definitely alternate. Now there's a key important message there. It says alternate angles are equal in measure. Alright? So alternate angles are always equal, which means whatever value is here is also going to be here. So if here is 30 degrees, for example, then here also will be 30 degrees. Alright? If this angle here is 150 degrees, then this angle here is also 150 degrees. So it's important to note that alternate angles are always equal. That's why we said there angle 3 is equal to angle 5. Now, if you observe carefully, the alternate angles are always formed in what looks like a Z or a letter Z, like you like to call it. Look here very carefully. If this and this line are parallel, that's the condition that they have to be parallel, and transversal, all right? This angle here and this angle here are alternate. And what does this look like? It looks like alternate angles are always found in what looks like a letter Z, all right? And of course, this can be rotated anyhow, because I could have it is going to look like this. If this line is parallel to this line, angle and this angle here also will be alternate. Sometimes letter Z in your diagram, the angle that letter Z are alternate angles. Okay. So moving along, we look at what we call corresponding angles. Now, this is when you have one inside angle and one outside angle that are on the same side of the transversal. All right? This time, one of the angles is inside, the other is outside, but they are on the same side of the transversal. That gives you corresponding angles, all right? If you look back to your diagram, if you take angle 6, for example, it is definitely an inside angle. Also, if you take angle 2, it is an outside on the same side. Yes, they are. So therefore, they are corresponding. All right? One is inside, the other is outside, and they are on the side of the transversal. Therefore, they are corresponding angles. That was just an illustration. You see there that angle 2 and angle 6 rather, and angle 2 are corresponding. Again, it's important to note that corresponding angles are always equal. So just like the alternate angles, corresponding angles also are equal. So if you know one, you have found the value for the other one because they are equal. Now let's try something. Apart from angle 6 and angle 2, can we find any other angles here that are also closely? You could 5 and angle 1. Angle 5 is inside. Angle 5 is outside, but they are on the same side. So therefore, they are corresponding. Again, you look closely. Angle 4 is outside, and they are on the side of the transversal. So they too are also equal. The same happens with angle 3, inside angle. 7 is an outside angle, and they are on the same side of the transversal. So therefore, they are corresponding and they are equal. If you observe and angle 5, and look at, follow my hand, and tell me what I have this. That's a line. And those that and F. So the corresponding angles are inside the F. And the F, of course, can be torn in different directions, but you still have the F. Then we move on to co-interior angles. Say these are two inside angles that are on the same side of the transversal. These are two inside angles that are on the same side of the transversal. So you can simply say inside, inside, same side. They are both inside and they are also on the same side. We call them co-interior angles. That is an example you have there. Angle 3 and angle 6. If you look at them closely, you can see that angle 3 is inside. Angle 6 is also inside, also side of the transversal. So therefore, they are co-interior. Now, apart from angle 3 and angle 6, which are identified as being co-interior? Clearly, angle 4 and angle 5 are both and on of the transversal, so therefore they are co-interior angles are supplementary. Remember, we have dealt with supplementary angles. We know they are angles that add up to 180 degrees. So co-interior angles, unlike our previous angles, are not equal. They add up to 180 degrees. So in this case, if you add angle 3 and angle 6, your answer should be equal to 180 degrees. So always, if you know one of the angles, of course, you can easily find the other one because you know their sum is 180. So if you know one, just subtract that from 180 to get the other one. Okay? And what letter do you think you can find these co-interior angles in? If you look at this, if you follow my hand, and this angle, they seem to be inside a U that is turned to face on the east. All right? Of course, if you have had it in this form also, it comes to look like an N. If this line and this line are, which means they add up to 180 degrees. And then we have what we call the vertically opposite angles. Vertically opposite angles. When two straight lines intersect, that means when two straight lines meet each other or they cross each other, the two angles opposite the meeting point. And remember, the point where two lines meet is called the vertex, all right? So the point or the angles opposite the vertex are called vertically opposite angles, all right? Now let's see an example. If you have this straight line and you have straight line, you can clearly see they meet at this point. So that's their meeting point, and that is their. So the angles opposite that vertex, like you know, and there's also another two angles opposite each other. We call them vertically opposite angles. All right. Likewise, if you look at this other, this angle right here, they are also the opposite this, and they are at the same point, and they are opposite. They are also vertically opposite. All right. Can we identify which angles here? And you can easily see 1 and 3 will be vertically opposite. 5 vertically opposite. 6 would be. And what do you observe? What does it look like? Line. You have another line. They cross. Looks like a letter X, right? So you use the letter X to identify vertically opposite angles. Again, that is just an illustration. You can see there angle A and angle B are vertically opposite. Likewise, angle C and angle D are also vertically opposite. And note that vertically opposite angles are equal, which means angle A is equal to angle B and angle C is also equal to angle D. Why? Because they are vertically opposite. Right, so we have a diagram here, and it says in the figure above, list down 16 pairs of corresponding angles. All right? We have a diagram and we are asked to list down 16 pairs of corresponding angles. Let's have the diagram here. Makes it easier. So it is from this diagram that we are supposed to list down 16 pairs of corresponding angles. Now that should not scare you. The number 16 appears big, but then I'm sure we can definitely get them from here. First, we know with corresponding angles is one of the angles is inside, the other is outside, but they are on the same side of the transversal. So to make life easy for yourself here, you can first focus on the vertical parallel lines and get all your corresponding angles from there, and then come and focus on the horizontal parallel lines, and then you will get the rest of your corresponding angles. Now, if we focus on the vertical parallel lines, therefore this C, the horizontal parallel lines will now serve as transversals, because they are cutting across the vertical parallel lines. So in that case, how we C, angle F, and M inside angles, all right? because they are found between these two parallel lines. Actually, we are focusing on parallel lines, all right? So 4 are found between the two horizontal parallel lines. So those are the inside angles. And then AB, IJ, HG, P, and O are the outside angles. So now we can start to list. What's our first pair? We are looking for an outside angle that are on the same side. Side A and E are, one is the other is outside, but they are on the same side. So I can say A and E. That's one pair. So there are 15 more pairs to go. Number 2, if we just move to the next angle, angle F is inside, angle B is outside, but they are on this. They also are corresponding. So I can have B, F, angle 3, number 3. So you have got 2 pairs, 14 more to go. Now let's start from D is an angle H is an outside angle, and they are on this. So they also are corresponding. So we can say D and H. So we've got 3 pairs. 4. Again, if you now take C, G is an outside angle, and they are sides. So you get number. Of course, we are done with here because you got angles that are corresponding here. So also, if you look closely, M is inside, I is inside of the transversal. So M and I are corresponding. N is inside, J is outside, so they also are corresponding. Number 6 will be A, N. So you have got 6 pairs. Then continuing to the 7, take angle L is inside, angle P is, and they are on the same side. So they also are corresponding. So L and P are corresponding. Or pair 8 rather. Angle K is inside, angle O is outside, but they correspond. K and halfway there, we have got for 16. Now look, you have angle CL still inside, JK, NO, DE outside. So we can use those again to get our remaining sets of corresponding angles. Like if you take E is inside, K is outside, but they are on this side. C and K are also corresponding. 10. If you come down here, angle F is inside, down the same side, so they two are. We move along. Still, if you go back to this L, inside, D outside, they are on the same, so they are corresponding. So we can say number 11, D number 12, M is inside, E at the same side, so they all correspond. Say E. Number 13. You have got DL already. Let's avoid repetition. We have got E and M and N. Yeah. We have got C, A. You have got C and K somewhere. Got 4 more to go. Now, also, if we take angle G very carefully, it's an inside angle, and we check angle O outside, so they also G. Angle P is an inside angle. H. So, is a same. Therefore, they also are corresponding. So you can say 14. That is angle H and angle P. H and we are. If you keep going, angle I is angle A is outside, but they are on the same side of the, so they also are corresponding. You can see and I. Only one angle now, right? And if you look very, B is inside, J is outside, on the same side of the, so they also correspond to B and J. There. And we were asked to list 16 pairs of corresponding angles, and we have been able to do. Okay? And with that, we come to the end of today. I hope you have something again.
Maria, even if you want lampican, you want cash for GB. Coach for fill a banta. Could you fill in a cash for Sana?
What over so good? What's the wrong Mamma Mandiba? Hello, Mamma. Abijan drunk for Tarant. To Karimbala, Yendi man and cash for a sign. Ha, Bantala.